So the name of this activity is inequality, mix, and match. So at the top of this table, you'll just see a list of different values, different numbers. Some are positive, some are negative. They're all rational numbers. Some are whole numbers, fractions, decimals, all that good stuff. And they want you to go ahead and complete this table, and you get to pick any of these numbers you want, and you compare them. So there's really a bunch of different combinations that you can do here. So here's a good example that's already provided for you. So statement 1 says -7/10 is less than 1. Remember, for inequality symbols, the mouth is always facing the bigger number. So in the statement column, you are going to be writing the inequality with the inequality symbol, and then to the right, you're going to be writing out that inequality in like a sentence form. So these are the same thing. -7/10 is less than 1. -7/10 is less than 1. And then I completed one more. So -2 5/10 is greater than -4, because remember, the greater the negative is, the smaller it really is. -2 5/10 is further to the right on a number line than -4 is. Now, one that I really wanted to draw your attention to is what I have written for statement 3. It says the absolute value of -8 is greater than 4. How is that possible? Because I thought we said that positives are always greater than negatives. Well, the reason is, remember, so absolute value is saying what is the distance of this number from 0. So what is the absolute value of -8 really? How far away from 0 is -8? Well, it's 8 units away from 0. So the absolute value of -8 is actually 8. Right? So anytime we have those absolute value bars, you need to think about not what just the number inside of the absolute value is, but what its distance from 0 is. So even though this is negative, because it's asking about the absolute value of this negative number, the absolute value is actually 8, which is greater than 4. So then my sentence would be, the absolute value of -8 is greater than 4. Okay, so that's kind of like the new piece that we're looking at today, is that including absolute values and inequalities, and making sure that when you're talking about absolute value, you are converting it and finding what its absolute value is. So at this point, why don't you pause this video and create your own inequalities and sentences. And then when you resume the video, I'll go over some other examples that I came up with. Alright, so at this point, I'm assuming that you have paused the video and completed this table yourself. And at this time, I'm going to just go over some more examples that I came up with, focusing really on working with these absolute values with the inequalities. So, as we discussed before, so anytime you see absolute value, what that's really saying is the distance of -8 from 0 is greater than 4, because the distance of -8 is 8 away from 0, and 8 is greater than 4. So in this next one, I said that -4 is less than -6/3. And the reason why, remember, fractions are division, and if I simplified -6/3, that's actually equal to -2, and -4 is less than -2. Another inequality problem, so anytime you see the absolute value symbol, you can either say the absolute value of 3 is less than -8, or we can think of it as the distance of 3 from 0 is less than the distance of -8 from 0, because the distance of 3 from 0 is 3, and the distance of -8 from 0 is 8. So, yes, the distance of 3 from 0 is less than the distance of -8 from 0. I'm not saying that 3 is less than -8. 3 is greater than -8, but the distance of 3 from 0 is less than the distance of -8 from 0. So it's really important when we work with these absolute values, we do kind of have to reorient our mind. Whenever you see this absolute value notation, your mind needs to shift to not the value of the number inside, but we're thinking about the number inside's distance from 0. So for statement 6, I said the distance of -5/2 from 0 is greater than 1. So once again, I used the notion that fractions are division. So I did 5 over 2, 5 divided by 2, which is 2 5/10. And so -5/2 is 2 5/10 units away from 0, and 2 5/10 is greater than 1. And so down below, I used that again because I had just found out that the absolute value of -5/2 is 2.5. And so for this one, this is the only one that I did that wasn't an inequality. This one was actually equal. So the absolute value of -5/2 is actually the same, has the same value as 2.5. Down below, once again, fractions are division. If you did 7 over 2, you would get 3 5/10. So 3 5/10 is greater than the distance of 3 from 0. And for statement number 9, just hit a simple one to close it out. 1 is less than 4. And so here is your lesson summary. Make sure to go through and read that closely, and then also to copy down your big ideas. So the big ideas today are super important. So number 1, the absolute value of a negative can be greater than a positive number because absolute value refers to distance from 0. So once again, for example, -5, the absolute value of -5 is greater than +3. So normally we've always said that negatives can never be greater than a positive, but this isn't saying -5. This is saying how far away from 0 is -5. And so the absolute value of -5 is actually 5, because -5 is 5 away from 0. And so what this is actually saying is 5 is greater than 3. So that's really important. We've got to pay attention to now. So when there's absolute value symbols, absolute values, the value of them will always be positive, because when we talk about distance from 0, we're always talking about that as we're just counting the spaces, whether it's left or to the right, it doesn't matter. And so that's why our second big idea is absolute value is always positive.